So let's talk a little bit about throttle position sensors. That's what we're gonna kind of discuss here. And let me get you a better view of my screen here on my scan tool. So I'm looking at a recording I just made of throttle position sensor 1 and 2. Okay. So taking a look at this, let's just kind of go over what we're dealing with here. Why do we have two throttle position sensors? Well, we on any modern day car, I mean, going back to the early 2000s, we have electronic throttle bodies, right? We don't have any mechanical linkage anymore. It's been that way for a long time now. So having two throttle position sensors is my fail-safe to make sure that this throttle body opens and closes correctly. So I don't have, say in an instance where this thing would try to accelerate away by itself. Okay? Whether that happens or doesn't happen, that's the reason we have two throttle position sensors. Now, throttle position sensor 1, it's going to be right here. It starts at a high voltage. Throttle position sensor 2 is right here. It starts at a low voltage. So right just with my key on, engine off, my throttle position sensor 2 is about 1.5 volts. And my throttle position sensor 1 was about 3.4 volts. And what I did not have the engine running. I wasn't using control functions in my scan tool, anything like that. I just opened and closed the throttle blade, slowly open and slowly close by hand to give you a visual of what takes place here. And you can see as the throttle blade starts to open, throttle position 1, the voltage drops down low, and throttle position 2, the voltage goes up high, and they're going to be proportionate to each other, as you can see right there. Now, if I had a sudden drop in voltage or spike in voltage on one of these, they are no longer going to agree with one another, and the engine control module is going to take the appropriate action, which its fail-safe is to close the throttle blade and reduce engine power. Well, closing the throttle blade itself is going to reduce engine power, but on most modern day vehicles, it also retards the cam timing and further reduces engine power. That's going to hopefully prevent somebody from having an accident. If it went the other way and the throttle blade went wide open and the car took off, well, then we're probably going to have some other issues that we're going to be dealing with. Now, so this is how a position sensor is going to work. So we could throw any position sensor name out there on any modern day car. Accelerator pedal position is the same thing, because I do not have a linkage between my accelerator pedal and my throttle body anymore. We have accelerator pedal position 1 and accelerator pedal position 2. They work the same way. Sensor 1 starts at a high voltage, sensor 2 starts at a low voltage. As accelerator pedal is depressed, sensor 1 is going to go to a low voltage, and sensor 2 is going to climb to a high voltage, and they have to agree with each other, just like you see right there on the screen. Brake pedal position, same way. We have two brake pedal position switches, so or sensors, sorry. I called it a switch. All these redundant fail-safes are put on these cars because we do things like shift by wire now, drive by wire. Partial self-driving vehicles are increasing every day. Eventually we'll have full autonomous vehicles, so there has to be a lot of fail-safes in place. It's another reason, I'm sure some of y'all have experienced this, it's another reason we have electronic parking brakes now. We no longer have a cable. So the control module in charge of the electronic parking brakes can apply that parking brake if there's an emergency situation, that's something that it sees that it doesn't like. Now, I will throw out a caution here. I am using my scan tool to record the voltages and graph out these throttle position sensor voltages for throttle position 1 and throttle position 2. Most scan tools, newer scan tools, have a refresh rate of about 1 millisecond. It's pretty fast, I get it, but sometimes our modules, in fact, I'd say in most cases on our new cars, our modules are faster than that in their refresh rate. So I'm looking at process data through my scan tool that gives me a capture every millisecond. If there's something that happens faster than that, I may not see it on my scan tool, and I'm going to have to revert to using an oscilloscope and connecting to my throttle position sensor circuits directly and trying to get a voltage reading that way. So just a couple of things to be aware of. If it's a smart sensor or a smart device, such as these sensors are, sometimes I may not be able to get a voltage reading with an oscilloscope because it takes a voltage signal and converts it to serial data and then sends it to the module. So I'm going to have my schematic know what I'm dealing with to know how to test it the right way. But either way, this just kind of gives you a visual of how these sensors work and how they have to agree and how they have to correlate with one another. Now I want to show you one more thing. These two throttle position sensors are powered with a 5-volt reference voltage from the engine control module. So let's take a look at something real quick. I got my meter hooked up to my 5-volt reference circuit over here. So if you look at my DVOM, it's reading 5.011 volts at my DVOM at my 5-volt reference circuit right now. Let's check the logic of these two accelerator pedal position sensors here, or throttle position sensors. Man, I keep calling these the wrong name. Let's check the logic here and see if it tracks. My voltages between sensor 1 and sensor 2 should add up to approximately 5 volts. So we're going to test that now. So let's look at accelerator or throttle position sensor 2, right here. Throttle position sensor 2. Its high voltage is 4.49 volts. So we get my calculator out here because I'm not very good at math. So 4.49 volts right there on my screen. 4.49. And I'm going to add throttle position sensor 1 low voltage here of 0.53. So plus 0.53 equals, and here we go. So that logic tracks. I added those two voltages together. I got 5.02. My DVOM shows 5.011. So this throttle position sensor is working correctly. So it's just a couple things you can look at when you're testing these style sensors, just to get a quick idea if it's working correctly or not. You know, why would I do this? Well, what if this thing, you know, maybe when I tried to accelerate, what if it intermittently stumbled or hesitated, and you know, maybe I had a check engine light, maybe I didn't. It's really going to depend on how quickly that fault occurs, or if that fault sticks around and meets all the conditions to set a code, right? So sometimes I have to dig deeper, you know, that I may not always have a code to go off of. So this just gives you a little bit more information to potentially help you diagnose a fault. Hope this helps out.